Hi everybody, so in this video we continue with Chapter 7, Geometry and Trigonometry. Specifically, Section 7.2, right-angled triangles and trigonometric functions of acute angles. So in this section, in the first couple of slides, you are going to find theory regarding right-angled triangles that you already are familiar with. So you're going to find the relationship between the unit circle and the sine and cosine functions, and also the definitions regarding sine, cosine, and tangent in relation to the unit circle. Then on the next slide, you're going to find the trigonometric ratios and an example of a series of triangles that are proportional, and therefore that means that, of course, the sine, cosine, and tangent functions would be the same. Then finally, you can see the values of sine, cosine, and tangent for common acute angles, meaning 30, 45, and 60 degrees. Now, what I'm more interested in is making sure that you guys do the exercises from section 7.1. It is very important to do all these exercises in order to get the basis for the IB questions themselves. And the last few questions always have a high degree of difficulty. So once you're done doing those exercises, you should go on or move on to the next subject, which is angles of depression and elevation. So in this first picture here to the left, we see a man standing, and this is his line of sight. He's looking at the top of the tree. Now this here would be a horizontal, and this is the angle of elevation. Now, because we have a right triangle, then obviously we can use the Pythagorean theorem to solve problems with these cases. Now, on the picture to the right, you see a different situation where there is a person standing on a cliff, and this person is looking down to a ship. So if you grab the horizontal, this is what's called the angle of depression. Now, there's something that I'm not mentioning here, but is very important. The angle of depression is actually equal to this angle here, the angle of elevation to the ship. And this makes things easier when solving the problems, mainly from a perspective point of view, because then you would have that this right triangle here is equal to this other right triangle there. So here we have example 7.5, and it says, determine the lengths of the missing sides in triangle ABC, given C is equal to 8.76 centimeters, angle A is equal to 30 degrees, and the right angle is at C. Give exact answers when possible, otherwise give to an accuracy of 3 significant figures. So we have to find A and B, and you guys know how to do this, but just for the record, remember that we could say that sine of 30 is equal to opposite, which is A, over the hypotenuse, which is 8.76. But this implies that A is equal to sine of 30 times 8.76. But we know that sine of 30 is 1/2, so this is 1/2 times 8.76, and therefore A is going to be 4.38 exactly. Now, for B, we can use cosine, right? So cosine of 30 is equal to B over 8.76. So we get that B is equal to cosine of 30 times 8.76. But we know that cosine of 30 is square root of 3 over 2. In this case, we will need a calculator because they want an answer that is accurate to 3 significant figures. So you're going to see that this is approximately 7.59. Now, let's not forget the units, right? So this is centimeters, 7.59 centimeters, and this would be for A, 4.38 centimeters. Now, of course, we could use Pythagoras in order to verify these results. And you will see that if you do the square root of 7.59 squared plus 4.38 squared, you are going to get approximately 8.76. So next we have example 7.6. where they say that a man who is 183 centimeters tall casts a shadow 72 centimeters long on horizontal ground. What is the angle of elevation of the sun to the nearest tenth of a degree? So we have that they want us to find this angle here. Now remember that this is a right triangle, so we can just use a trigonometric ratio. In this case, we have that these are the legs of the right triangle, and this would be the hypotenuse. Then we can use opposite over adjacent, which is tangent, right? So we have that theta is equal to the inverse tangent of opposite, 183, over the adjacent, 72. And if you plug this into the calculator, it's going to give you approximately 68.5 degrees, rounded to 3 significant figures. Very well. We continue with example 7.7. And it says that during a training exercise, an Air Force pilot is flying his jet at a constant altitude of 1,200 meters. We can see that here. This is 1,200 meters. His task is to fire a missile at a target on the ground. At the moment he fires his missile, he is able to see the target at an angle of depression of 18.5 degrees. So this is the angle of depression here. If the missile travels in a straight line, what distance will the missile cover to the nearest meter from the jet to the target? Okay, so to make things easier, remember that this angle is equal to this one over here, right? So this is 18.5 degrees. And we obviously have a right triangle. So all we need to do is decide which trigonometric ratio we can use to find x, which is the distance between the jet and the target. So we know that we have to use the sine function, because sine of 18.5 degrees is equal to 1,200 divided by x. That means that x has to equal 1,200 divided by sine of 18.5 degrees. And plugging that into the calculator, it's going to give us approximately 3,781.85. But they want us to round, they said, to the nearest meter. Okay, so we have to rewrite this as 3,782 meters, and that would be the answer. Very well, we continue with example 7.8. And it reads that a boat is sailing directly towards a cliff. The angle of elevation of a point on the top of a cliff and a straight ahead of the boat increases from 10 degrees to 15 degrees. So at first the angle of elevation here was 10 degrees, and then it got a little closer and it was 15 degrees. As the ship sails a distance of 50 meters, so there was 50 meters between here and here. And then they say find the height of the cliff. So they want us to find the height of the cliff. So notice that we have two triangles here. This is one triangle, one right triangle. Would be this one with a 15-degree angle of elevation. But we would also have one with a 10-degree angle of elevation. And everything should be in terms of h and x. So what we're going to do is that we're going to go to the next slide where I have separated those two triangles in order to solve this problem. So let's erase this and let's move on to the next slide. So here we are on the next slide, and we've separated the triangles, as you can see. So for this first one, we know that tangent of 15 is equal to h over x. Therefore, the height, which is what they want us to find, is equal to x times tangent of 15. All right, so for the next triangle, we have that tangent of 10 degrees is equal to h over x plus 50. Therefore, h is equal to x plus 50 times tangent of 10 degrees. Okay. Notice that this has two variables, so we're going to have to solve for x first. We do know as a fact that x tangent of 15 must equal x plus 50 times tangent of 10. That's because these two also equal h, so they have to be equal. So let's solve for x. So notice then that we can rewrite this as x tangent of 15 is equal to x tangent of 10 plus 50 tangent of 10. Then we can move this to the other side, and we can factor out x. So we're going to get x times tangent of 15 minus tangent of 10 is equal to 50 tangent of 10. Now notice that I'm not calculating 50 times tangent of 10. I'm doing that till the end. That's what I suggest you guys should do as well. So then we have that x is equal to 50 tangent of 10 divided by tangent of 15 minus tangent of 10. So this is x, and I'm going to leave it like that. I won't change it until the end when I want to round. So going back, we see that h is simply x times tangent of 15. So that means that h, which is equal to x times tangent of 15, would be the same as saying that h is equal to 50 tangent of 10 divided by tangent of 15 minus tangent of 10 times tangent of 15. Now we finally plug this into the calculator, and it's going to give us approximately 25.783. But we have to round it to three significant figures. So we have that the height is approximately 25.8 meters. Very well. So here we are in example 7.9, which will be the last one on this video. So it says, using a suitable right-angled triangle, find the exact minimum distance from the point 8.3, this one here, to the line with the equation 2x minus y plus 2 equals 0. So this linear equation here, this line. Okay, so notice that if you want to draw the smallest distance, it would be a perpendicular line, as you can see here. That's why you have that perpendicular line. Therefore, you have a right angle here, and then we're using a right triangle for this as well. And they want us to use this to find d. Now, there's several approaches you can use, but the one I'm going to use here is by equating two different ways of finding the area. So notice that we can find the area of this triangle very easily by just using the fact that this distance here, the base here, is the difference in x. So that means that this base is going to be the absolute value of 8 minus 1/2. And that equals 15 halves. So the base is 15 halves. Now for the height, all we need is the absolute value of the difference in y. In this case, it's 18 minus 3, therefore 15. So the area, the total area of the triangle and the figure is going to be 1/2 times the base, 15 halves, times the height, which is 15. And this equals 225 fourths. Okay, so now we have to compare this area to another way of finding it. What's the other way of finding it? Well, if you look at this here, the hypotenuse is actually also a base, and d would be the height of the same triangle. So first we need to find that hypotenuse. The hypotenuse is simply going to be the square root of difference in x squared, so that means 15 halves squared, plus the difference in y squared, which is just 15 squared. And if you plug this in the calculator, it's going to give you 15 square root of 5 halves. Okay, so we're almost ready to solve because the areas are the same, it means that 1/2 times the base, in this case we're using the hypotenuse, so 15 square root of 5 halves times the height d must equal 225 fourths. So now we have a simple equation, and all we have to do is solve for d. So if you solve for d, you should get that it equals 3 square root of 5. Then the answer would be that the minimum distance, we don't have any meters or centimeters here, so we'd have to say that the minimum distance from point 8.3 to the line would then be 3 square root of 5 units. And now the reason we leave it in terms of the square root of 5 is because they're asking for the exact minimum.